Alright, so there's our heading. Today's date is the 4th of the 2nd. Distance, speed and time. So you can write this down if you want. You can wait for the PowerPoint to come up. Essentially this is just talking about speed as an idea in terms of mathematics. So it just compares two other things. So it compares distance and time. That's all speed does, is compares distance to time. And when we're talking about distance, we're talking about speed compared to time. And then when we're talking about time, we're talking about speed compared to distance. So we're sort of comparing all three of those things in some way, shape or form. Okay? We've got pretty good speedometers these days. The digital speedometers in cars are pretty good. But they're still not totally accurate. They used to have a tolerance of plus or minus 10%. They've improved on that a little bit. And GPS devices are pretty good as well. Most GPS devices are pretty good. So that's pretty much just about speed. Alright? How to work out distance, speed and time. We've got our little stop sign, or our little road sign here. Distance, speed, time. Alright? I'm hoping you have seen that before. Alright? So, D obviously distance, S being speed, T being time. How do we work out distance? Well, we times speed and time together. Alright? So distance is speed times time. Makes sense, doesn't it? Yeah. Distance, speed times time. Yeah. Speed is distance over time. That's why we set up our road sign like that. So speed is distance over time. Distance over time. Distance over time. So what would that make time?
Speed times distance.
Distance over speed, won't it? Because it's set up nicely in our diagram. Are there any questions on that? And how that works out? And you're welcome to redraw that in your book, or you're welcome to wait for it on the Google Classroom. Here's our first example.
Are we writing that?
We're going to write all this down. Finding your speed and time. And there's our first question. Our first question is, find the distance travelled by a car whose average speed is 65 kilometres per hour if the journey lasts for 5 hours, and we want to the nearest kilometre. So with this question, ladies and gents, there are two really important bits of information. Well, there's four, but two really important bits that we cannot do this question without. Alright? One of those bits is this, the 65 kilometres per hour, and the other bit here is the 5 hours. Can't do this question without those bits of information. Alright? We're finding the distance, we need these, and this is the accuracy we want. So there are four important things that we need from that question. The rest of it is pretty just superfluous. It's a little bit like fluff and waffle. But they're the important bits. We want to find the distance. There's our speed. There's our time. That's our accuracy. Now going back to substitution, what was the first thing we had to do?
Oh no, you told us.
When we were doing substitution, what was the first thing we did? We wrote the question down, didn't we?
Yeah.
So it's going to be the first thing we do for this as well. Write our formula down. Right, what it is we're actually going to be doing. Alright, it makes life so much easier when we're working out those bigger, harder sort of questions, those multi-part questions. Alright, what did we do next? What was the next step? So we've written down that formula. What was the next step? Changing the variables. So we've got speed and time are the things that we know. So we can substitute those in. Alright, so 65 for speed, 5 for hours. Does that make sense?
Yeah.
Alright, they're the bits that we need because we want to find distance. We don't know it yet, so we leave it blank. 65 and 5. Then what do we do? Think about what we did for substitution. What did we do?
Evaluate.
Evaluate. Let's evaluate it. What is 65 times 5?
325.
325. Now, here's my question. Am I finished?
No.
What do I need to add?
The
kilometres, because what was I asked to do?
the nearest kilometre.
Nearest kilometre. So I need to add that in to tell our whoever's reading it what's going on.
Yeah.
Alright? Any questions on that?
Any other question?
There's our next question. How long will it take a vehicle to travel 150 kilometres at a speed of 60 kilometres per hour? How long will it take a vehicle to travel 150 kilometres at a speed of 60 kilometres? So what is this question asking us to do? Find the time. It's asking us to find the time. It's asking how long. It's asking us to find the time. What information does it give us?
150 kilometres.
150 kilometres, which is?
Distance.
Distance.
And then kilometres. 60
And then
kilometres.
it gives us
Which is the speed.
the speed. Yeah?
Smart.
Gives us all the information we need. Okay?
Google's that weird.
Now, one of my little tips is when you get questions that look like these ones, that are like a sentence long, and you've got to pull information out of it, do exactly what I've just done. Circle it, highlight it, draw things around that bit, those bits of information, so that you can get rid of all the extra bits. So you can focus in on what you actually need to be able to answer the question. Okay? Because sometimes they will actually put in extra bits of information that you don't need. So this question here, it might say, on a Sunday morning with the sun in your eyes. Do you really need to know that it's a Sunday morning and the sun's in your eyes?
Yes.
Not to answer this
It's
question.
detailed miss.
Alright? So you've got to be able to pull that information out. What am I going to do first?
Right.
What did we do first over here?
Distance times speed times.
We wrote the formula down. What's the formula going to be this time? Because we're looking for time. Time equals distance over speed. Alright. Hopefully that's fairly straightforward. What's the next bit? Substitute in. What am I going to substitute for where?
The kilometres.
It's going to be 150 over 60 because it's distance over time. So distance over the speed, sorry. Now what? Evaluate. Evaluate. Do you think that's finished?
No.
What's missing?
Hours.
The hours. Exactly right. Because we've got 60 kilometres per hour, don't we? So we've been told in the question what we should put our time in as. Hours. If that said 60 kilometres per minute, which would be going very, very fast, then we would put minutes at the end, not hours. Does that make sense?
Yeah.
Okay, so the next bit is all about stopping distance. So just read these bits. You don't need to write these 3 bits down. They're just there to tell you a little bit more about stopping distance and why it's important to understand stopping distance. Alright? Because this is talking about how long it actually takes, especially if you're behind the wheel of a car, which most of you will be starting to do if you're not already doing it. From when you see the thing you need to stop for and when the car finally actually comes to a stop. And that stopping distance will change depending on how quickly you're going and how quick your reaction time is. Okay? And this is the basic formula. Okay? Your stopping distance is your reaction plus your braking. Okay? So your reaction time might be really quick, but to actually move your foot from accelerator to brake, and then for the car to actually slow down and stop, will take a little bit longer. Could take quite some time. why school zones are at 40 k's. Alright? That's why we have 40k school zones. That's why some of the places in Canberra and other places like Goulburn and Sydney and whatnot have pedestrian zones that are only 40 k's.
Because there's a lot of people.
That's why most suburbs are 50k zones rather than 60 or 70. Okay? It's because stopping distance is important. Reaction plus braking. So we have D for distance.
T for time.
D for distance. T is your reaction time. So it's not just time in and of itself, it's reaction time. So it's that time for your brain to see something happening and then react. Alright, and we can potentially do some measuring of that for each other. Maybe not this lesson because we're a bit strapped for time for this lesson. V is velocity, so that is the speed the car is actually travelling at. Okay, so we've used S for speed, and now we're using V for speed. So V for velocity, V for speed. Make sure you have this formula written down in your books. We're going to use it for our next example. Hopefully you've got that down. Let's do our, like I said, you don't have to write these three down. It's in the PowerPoint, you'll be able to see it when it goes up on Classroom. Make sure you've got the formula. Okay, here's our question. I'll give you a minute or two to write the question down. You've been given the formula in the question as well. We've got Trevor. Trevor is driving at a speed of 45 kilometres per hour. He had a reaction time of 0.75 seconds, so that's pretty quick. Hazard has come up. Alright. Hazard has come up. He's driving through the school zone, he's going 5 k's over the limit in the school zone, and a little kid has lost his ball across the street and he's darted out between some cars. Calculate the stopping distance using the formula D equals 5VT over 18 plus V squared over 170. Answer the nearest whole metre. Alright, let's see if this Trevor can stop in time.
He's done it.
What's the question asking us?
If he's going to stop in time.
So what's it actually asking us to do though?
Oh.
What's it asking us to do?
Find how many meters it'll take for him to stop.
No. Calculate the stopping distance. Got a whole sentence in that question until we've actually found out what it wants us to do though. So that's why we've got to make sure we're reading questions carefully. Okay? What information do we need out of that question?
The kilometers and
solution.
his reaction time.
Yep. Our speed,
The solution.
our reaction time. We're going to do our solution ourselves, Ben.
What's that thing down below reaction time then?
You mean the formula?
We need the formula then.
We do need the formula.
I suppose.
One more piece of information that we need to know about.
Nearest whole meter.
Nearest whole meter. We need to know what the accuracy is that we need to be at. Okay? We need to know that information. What am I going to do first, guys? What have I done first this whole time? Now what? I'm going to substitute in. What's going to go where? What am I going to put in for V? I've got two V's. What am I going to put in?
Speed.
The speed, which is?
45 kilometres.
I'm going to chuck the 45 in. What's going to go in for T? The 0.75, because that's our reaction time. So there's our first fraction. Alright, so see how I've broken it out? 5 times 45 times 0.75. Plus the second fraction is 45 squared over 170. Now in my working, I have gone through and I've worked out bits and pieces separately, just to show you guys what's happening. You can write all the working out if you'd like. Alright, so I've then gone, alright, so what is 5 times 45 times 0.75? Well, turns out it's 168.75. 45 squared is 2,025. Right, so I've worked that bit out. Then I've gotten rid of my fractions. Worked out my fractions, added these things together. Now I did round 11.91. I have rounded that to 2 decimal places. I have rounded that to 2 decimal places. I'll let you know that now. It's got about 20 of them. My advice to you is to try not to round that low this early. I've just done it for space. Try to go 4, 5 or 6 decimal places. It will make your answers at the very end so much more accurate. Okay? Add these together. This is what I get. 21.285. What is that going to be to the nearest whole metre? Somebody?
$21.
21?
Yeah.
Does anyone disagree? Good, because it's 21. Is my answer finished? What do I need to add to finish off my answer? Minutes. You can just be an M if you want, or you can write out the word meters. So, let's think about this. We're driving down the street. We're going about 5 k's over the speed limit, because we're in the school zone.
Wait.
2 cars ahead. The ball comes flying out between 2 cars and a little kid comes chasing after it. Is Trevor going to be able to stop in time?
No.
I'd hazard to guess at 21 metres, that child is under his car. 2 car lengths. Think about what's 2 car lengths. 2 car lengths is not 21 metres, is it? Right? This is one of the reasons why we must be obeying speed limits. If you really wanted to, you could go and work that out at 40 k's
But really,
and see if he actually stops in time at 40 k's.
that's pretty much guitar.
Yeah. But if you're going 5 k's over the speed limit, that's why we have 40 k zones around schools.